So yeah, my name is Fergal Walsh. I'm a backend developer at Hippo. Hippo is a product consultancy based in Istanbul. We're a multidisciplinary team of about 25 people. Hippo is spelled wrong because it's in Turkish, so it's Hippo with one P. So today I'm talking about rethinking how we build HTTP APIs, and specifically about a framework called Pico, which I develop. I've highlighted build here because I'm not talking about different API paradigms or different types of HTTP APIs like GraphQL or something like that. No, I'm talking about more traditional JSON over HTTP APIs, but specifically how we build those HTTP APIs from Python. So, if we want to build an API in Python, let's forget the HTTP for the minute and just say we want to build a simple API. We have a module. Okay, sorry, this is the API we want to build. So API with a hello method where we pass in some string and we get back some result as a dictionary. So in Python, it's pretty simple. There's no boilerplate at all. It's just a simple hello function. We pass in some string and we get back a dictionary. Now let's say we want to turn that into a HTTP API, just so we're all on the same page here. So we have some URL which we get, and we pass in some query parameter. So for example, here we're saying the parameter who should be world, and we expect to get back a message as JSON. So there's many ways we can do this in Python. There's many different frameworks. There's Django. So in Django, we would do something like this. This is probably the minimal possible Django you can have. So this is a Django view. We get the request object. We get our argument out of the get dictionary of the request. We interpolate it into our string. We basically do our business logic. And then we return a JSON response with our dictionary. And then we set up the URL routes for that. Django framework, it's slightly different. We use class-based views, and how we access the parameters from the dictionary is slightly different, but it's quite similar. In Flask, we don't separate the routing from our view function. We use a decorator instead to specify the route. And then the request object itself is a global, and then we access the arguments from that, and then again we return JSONify and with the arguments that we want to turn into JSON. Flask-RESTful, again, is a class-based view version of that. And then there's Pyramid, which again is something like this. So we use decorators here to give the route a name and to specify how it's going to be rendered. So in this case, it's JSON. It could be some other output format like HTML or XML or something else like that. But the internals are relatively similar. And then in Tornado, it's a bit different because Tornado is different. Tornado is a concurrent asynchronous web framework. You can have lots of weird fun with Tornado. Personally, I had quite a long time of Tornado hell, so I quite dislike it at this stage. But you can do some very cool stuff if you have a very limited domain. But you don't return things from Tornado generally. You write to the output because you can keep on writing to the same output stream for a long time. So it's quite useful like that. But again, we have the same type of thing. We get arguments, and then we do something, and then we write out some JSON. So you can see a common pattern here, I think. This is how most frameworks work in Python. We have some function which takes a request, or else we get the request as a global. We get some arguments from it. We do our logic, and then we return a response of some kind. Sometimes that response is automatically converted to JSON. Sometimes we pre-process it into JSON. But in general, we return a response of some kind. The alternative is the class-based version of that, where we have, say, a get method and a post method and a put method on one class. If we go back to looking at our original function, we see that we've added quite a lot of extra code around or inside our function to get the job done. And to me, this extra code is a bit unnecessary. There can be a cleaner way that we can do this. So this is where we import Pico. This is where Pico comes into this talk. So in Pico, actually it looks very, very similar. We have a function. It takes an argument. It doesn't take a request object. It takes an argument. It does its logic and then returns a dictionary. So actually our function here is exactly the same function that we originally defined in Python. So we can forget that we're writing a web request handler here. It's just the same function. But we decorate it with pico.expose. This tells us that we're exposing this function to the world. And then we register this module itself with the Pico app. And then this app is a WSGI application. So this can be served by any WSGI server. This is exactly the same model that Flask or Workzeug or Django or all those other WSGI frameworks work, except for Tornado, which doesn't work like that. So what Pico does is passes the data we need from to our functions as arguments. So it takes the arguments out of the request object and passes them to our function for us. It serializes the data we return as JSON. So we return a dictionary, it turns it into JSON. It's always JSON. There is no option on that. You don't return XML. This is JSON over HTTP. This is an opinionated framework to keep things simple, and because, come on, everybody uses JSON these days. And we don't manually specify the URL that we're going to use for this. Instead, Pico automatically determines the URL from the module and the function name. So in this case, if this module is called API, if this is api.py, then our URL becomes api/hello, because our function is called hello. It keeps things simple. And most importantly, we write framework ignorant from function bodies. That means there's no framework code inside the body of our function. So if you ever want to convert a function into an API handler, we just decorate that function, but we don't modify the internals. So no framework code inside our functions. Okay, so what? That's not really that important, is it? Well, it has some advantages. So I don't know about you guys, but when I'm developing, I'll always have an IPython console open beside my editor. And I'm always iterating on the code in IPython, trying things out in real time, and then adding them to the code that I'm developing. So I like to keep things simple, make it easy to import and run in IPython. So if you have defined your module in this way, you can still import the API module, and you can still call your function and pass in arguments as strings, dictionaries, lists, Python objects, etc. And you still get back a Python object as your result. So you can pretend that it is not a web handler at all. It's just a normal Python module with a normal function. This also makes it easy to test. So if we want to test our functions, we don't create a client for our framework to imitate HTTP requests against our application. No, instead we just use normal unit test, and we write the tests exactly as we normally would. Inputs, pass in some inputs and assert the outputs. It's also easy to compose, which by this I mean that you can call other functions. So if you have some function that you have exposed, so like our hello world function here, our hello function, but we also want to use that internally from another function, well, we can easily do that because it is still just a normal function. It is not tied to a request object or anything like that. It's just a function that takes some Python standard types and returns some standard types. Okay, so probably, maybe you're thinking this is nice, maybe you're thinking this is the most awful thing ever, that's okay. But probably you're thinking, okay, this is just another hello world framework, can't really do very much. Real code obviously needs to access the request object. You need to do authentication. You need to access headers from the request, etc. So let's give an example of, say we have a movie service and we want to list the movies, but we want to filter by the IP address. So based on the country, the user should get different movies. So we could do something like this. Request is pico.getRequest, so we have a function which returns the request, the current request, and then we get some attribute from that. So the remote address is the key in the request environment to get the IP, and then we do some logic based on that. And then we continue with our interactive development. We import our module, we call the thing, we get a key error, okay, because, well, we don't have a request. Okay, so we can import Pico, and then we can set up a dummy request where we pass in a dictionary some environment, and then we continue. Yeah, this got a bit painful. This is not so easy anymore. So this is the way that I originally went, and I thought, it's fine, it will do. And I used this framework like this for a while. I didn't have that scenario very much. I mostly used it for internal things. I didn't really need very much from the request object, so I just ignored it for a while. But it was the wrong way. It wasn't nice. So I reminded myself that there's a rule in Pico that no framework code should be inside our functions, and we should try to stick to this. So then I started thinking about decorators. Is there a way that we can use decorators to inject things into a function so that the internals of our function can stay the same, but we can inject data into it when we need it? And can we have a decorator that is only active when it's been called in the context of a web request? But if I just call that function normally from within another function or from a Python console or in a script, that it just does nothing. And yes, we can do this with decorators. So the solution to this is a little decorator called request_args, which takes some keyword arguments, where the argument name is the argument for our function, and the value of that argument is a key in the request environment. So what this does is pass the remote address from the request object as the IP argument to our function when it is called in the context of a web request. So our function now, it depends on the IP address. So we give the argument of an IP address to our function. But that is automatically passed by the framework when it's needed. So then we still have our easy development. We can just pass in our IP address here as a string, and it still works. We can still test it in the same way. But in the context of a web request, that argument gets automatically populated by the web framework. We can also do a little bit more complicated things, like if we pass a function as an argument to request args, then we can actually have a function which operates on the request argument, on the request object, and returns something that gets passed into our handler function. So in this case, we want the username of the user who is currently logged in. So we can have a helper function called current user, which operates on the request, and it can do whatever you want to actually work on the request to get the things that you need. So in this case, we're assuming that the user is being authorized by basic auth, and then we're going to return the username here. So then our function is only dependent on the username. It's not dependent on the request object. It's not dependent even on the user object. It's just dependent on the username. We can also do things like if we need to check if the current user has permission to do something, then we could pass in the current user and do the thing, otherwise we raise a forbidden exception. But if we do this, then we're still unnecessarily coupling our function to the user object. But in reality, we're just using that user object to check if there are permissions. We're not really using the user object for the logic of the function itself. So this is where the concept of protectors comes in. So a protector is a function which is called with the request object as an argument, and it can do some checks to see if this operation should proceed or not. So if it returns false, or sorry, if it returns true, or if it basically if it doesn't return false or raise an exception, then it's okay. Things will proceed as normal. So in this case, we're not actually using the user object. So we just want to check if the user has permission. So we set a protector with this isAdmin function. If the user isn't an admin, then we raise a forbidden exception, and nothing in the inside of the function gets executed. But again, these protectors have no effect outside of the request context. So if we're using this in a script, well, we assume that we have permission to use our functions of our API. If we're calling it internally from another function, then all of those decorators are just no ops. So these decorators, they add some internal complexity to the code of the framework. Writing decorators that actually work properly in all cases is a bit of fun. You end up with a lot of nested functions, even when you use helper libraries like wrapped. And it's important to do this right, because especially in something like Pico, where we need to inspect the functions and we need to check the arguments that a function takes, and we need to access the function names and the function doc strings and all those things. So we want to make sure that they are maintained properly when we decorate the functions. So there's some internal complexity, but you can ignore that. You get a cleaner UI user experience as a developer at the cost of some complexity inside the library. But that's fine, I think. So I briefly mentioned that the routing is based on the names of the module and the function. So this is basically exactly how it works. So if our module is called API, then the URL is generated as module/function name. So it's example.com/API/hello, and then the quargs are passed as URL parameters or by post as in the body as JSON, or also as form encoded if you need that. It will work any of those ways. And then if you have a larger application where you have a package and then you have multiple modules in it, then the URLs are structured in the same way. So you have package, module, function name. So one URL maps to one function. This has the advantages that you can quickly find the relevant code. If you have a URL, you immediately know what function you go to check. It limits the mental overhead you have when you have a big project, lots of API endpoints. You have lots of functions, but you immediately know which map to which. And most importantly, I think, is you don't have to care about how you name your endpoints for your API. So usually we have to go through multiple processes of naming things, and we all hate naming things generally. And most of the time, it doesn't matter. It's not really that important. We shouldn't care so much about how we name resources in URLs. A lot of people would disagree with me, but that's my opinion, and that's the opinion that is baked into Pico. And I find it very relieving to not have to think about naming things. So I just name it once, and then I don't have to think about, should I name my URL the same way, or should I have a different naming scheme? It's set for me. Okay, so you may be wondering, what about URLs with multiple HTTP methods, like a REST API? Usually we have something like get APIs/users, post APIs/users, get API users 1, put API users 1, etc. Well, Pico purposely doesn't support this because we want to have one function per URL. Instead, the way that I write this, and the way that I encourage Pico users to write this, is to explicitly name your functions. And so you have a list users function, and you have an add user function, and you have a get user function, and an update user function. I think that's how we would write it normally if we're writing an internal module in Python. So why not write our URLs the same way? Keeps life simple. Okay, now you're probably, maybe you're appalled because this is not RESTful, or maybe you're like most developers in the world who actually don't care. Maybe RESTful is not that important. So Pico APIs are not RESTful. And I don't apologize for that, because HTTP APIs do not have to be RESTful, okay? At some point, we tried to turn everything into REST, and most of us only did it in a half-assed way. We didn't really follow REST, and then we came up with this word of being RESTful, which was, I don't know, it's kind of REST-like, but it's not fully RESTful. But why do we bother? I mean, the most important thing is that we stick to something that is simple like JSON as our encoding of our data, and having using good error codes, using proper HTTP statuses. So basically, simple JSON over HTTP is what we need. So from my perspective, I think by not trying to be RESTful, not explicitly trying not to be RESTful, but by not trying to be RESTful, we relieve ourselves of a huge burden and a lot of debate about correctness and about naming and all sorts of irrelevant things. So Pico, first and foremost, tries to be pragmatic, optimizing for ease of use and ease of development instead of theoretical correctness. So there's some other aspects to Pico's pragmatism that I'd like to briefly mention. The handler functions are designed to be simple, basically as simple as you can possibly get. Just use JSON, I already explained. And then automatically serialize JSON. So, for example, if you try to serialize a datetime object with normal JSON, it doesn't work. Or if you try to serialize a NumPy array with JSON, it doesn't work. But it should work. I mean, we should be able to do this. So Pico is has a slightly extended JSON that automatically does serialize these things, because it just makes life easier. So you need to know how it does it, but once you know that it's going to do it for you, you can forget that. Sensible, simple URLs, as I described. Self-describing, which I'll describe in a minute. It supports passing the arguments in multiple ways. So you can for a simple request, you can just pass them as query parameters, but if you want, you can pass JSON by post, or you can do form encoded. So it's basically up to the client to decide how they want to send data to your API. It works with any HTTP client because it is just normal HTTP. Pico in the framework includes a Python and a JavaScript client. So you can actually call another Pico service from Python with the Python client, which is great for setting up microservices, or just any two services that need to talk to each other where you don't need to call them microservices, but just two services that want to talk to each other. Or if you have a front end written in JavaScript, then, well, there's a JavaScript client built into the framework. And then I fully understand that I can't possibly think of everyone's use case, so I've tried to make the framework in a way that it's easy to override certain parts where you need to for your own specific domain. But there's a limit to what you can do, of course. I mean, if I tried to make it all overrideable, then it would be useless to anybody. So some parts are overrideable. If you want to override others, well then, I don't know, you're probably going to end up rewriting the whole thing from scratch. So some of it is extendable and overrideable. And very importantly, I think, is that it's deployed just like any other WSGI application. So WSGI is a very well-known standard. Yes, it has limitations for things like streaming and WebSockets and those sorts of things, but for normal HTTP, it's basically perfect. It's very well understood. There's lots of application containers and servers that support WSGI. So the way that you deploy a Flask application is exactly the same as how you deploy a Pico application. So the self-describing bit. Imagine that we have a module like this. It's basically the same as before, just notice that we actually have some doc strings now. And one of these methods is decorated as requiring post. So we can't get to this, we need to post to it. So if we go to our web service and then /API, so which is just the name of the module, then we get back a description of that service. So it gives us the URL itself. It gives us the doc, which is the module doc string. It gives us the functions, their names, the URL for that function, just so you don't have to generate it yourself. It gives you the doc string for that function. And then it gives you the arguments that that function requires, as well as their default arguments if they exist. And then if it's restricted to a specific method, it will tell you that. The reason for this self-describing bit is so that we can have these clients where we automatically generate the client that we need. So there is a Pico.client module, and there we can load a Pico service from some other remote URL. And then we can call the functions on that in RPC style. So we pass in some data to the functions, and we get back some results. We pass in Python objects, and we get back Python objects. We don't deal with the JSON anymore. That's what the client handles. And if we open this up in IPython and we do the normal thing of checking we want to get the help for the function, we still see that it acts like a normal, proper Python function. So you don't see some automatically generated garbage. You see the proper arguments that this function accepts, their default parameters, the doc string. So you can easily just load the module that you're going to work with remotely, and then start playing around with it, work out what you're going to do, and then use that in your code. And then the JavaScript client works very similarly. You load the pico.js, which is the client, and then you load the module, which is basically just by appending .js to it. It loads a JavaScript definition of the module. And then later you explicitly import that. That doesn't do an extra, it's slightly different to the way that the Python one works, because in JavaScript things are happening asynchronously. So we explicitly load the module at the start, and then later we import it explicitly. And again, we just call API.hello, pass in some parameter, and then it returns a promise. So then when that has returned, we do our JavaScript callback thing and modify the UI. And then there's some extra helper methods built in, but generally it's the same thing as the Python client. All the functions are automatically generated. You have the help strings if you are using the console. And you can post using form data or using JSON here. Okay, briefly, I want to mention where this came from. So, in a previous life, before I was a professional software developer, I was a researcher, an academic researcher. And so I originally developed this around the time that I was starting doing my PhD. And we were doing a lot of, so I worked in a lab where we were dealing with spatial data, and we were applying some machine learning models to spatial data and doing a lot of data analysis. And the thing that we realized was that all the great analysis tools are in Python, but all the good visualization tools, especially for spatial data or network data, are in JavaScript. So you have things like Leaflet, or back in the day it was Open Layers for spatial data. You have things like D3 for doing amazing interactive data-driven graphics in JavaScript. And on the Python side, you have some options, but it's a bit more limited, especially when you want to get interactive, unless you want to go down the whole like desktop GUI thing, which we didn't. So we built this tool, which originally was part of a Django project, actually. And the main aim was to ease the interaction between server-side Python and browser-side JavaScript. And then eventually it was part of a larger Django application, but eventually we realized that we were only using a very small part of Django. And mostly we were just passing some parameters to call some functions on the back end and then getting those results, passing them to the browser. So I realized that this could be extracted into its own small little framework. I heard that small frameworks were the thing back then, so I thought it would be cool to have a smaller than micro framework, hence the Pico. But now that I am away from writing research quality code, I now write API services for a living. And Pico is now used in production services. Some of them are small microservices, we can call them, because they're just single modules. They only have a few functions. Some of them are multi-module projects with more than 100 public endpoints. And it works for those. There are various other users out there using the library. I occasionally get emails about it, but I have no idea about the actual usage stats. But along the way, I definitely made some mistakes, which I'd like to share because I learned some lessons too. So originally, Pico was a bit more magical. It was ridiculous, actually, when I look at it now. So the first line of the README was, literally add one line of code, import Pico, to your Python module and turn it into a web service. And that's all you had to do. So you didn't have the Pico.expose, you didn't set up the app, and all those things were implicit. And I thought this was amazing, because you write less code. What's not to like? But yeah, nobody else really thought that. It took a lot of explaining to get people to understand why or how it could possibly work like that. And Flake 8 didn't like it. Flake 8 always complained because you're importing Pico, but you're not using it. So that was a good enough reason to reduce the magic. And yeah, I tried too hard to be to make it as a single file framework. I don't know why that was a thing, but it was at some point. Bottle famously was one giant, well, not very big, but one file. In Pico, it even had the JavaScript inside the same file. I think at the start I didn't really quite understand how libraries should be packaged and distributed and things, so I thought it's easier if you can just copy and paste pico.py between your projects. But yeah, obviously it's much easier, much better if you just separate things. And then I also tried too hard to have no dependencies, basically based on the same reasoning. I kind of was fed up with frameworks that required you to install a load of things, and nowadays it's got much easier with wheels, but back then it was like installing Django, especially GeoDjango, if you're using the GIS extensions for Django, was a real nightmare, because there was a lot of C dependencies and things, and then that kind of put me off dependencies. So, and I wanted to learn. And I kind of used this project as a chance to learn how all these things work. So I implemented everything from scratch, including static file handling, HTTP errors, requests and responses and all those things, which was a great learning experience, but I mean, that's not how you write a framework that you expect other people to use. So when I rewrote Pico 2, which is basically taking the idea of Pico and then doing it properly, I built it on top of Workzoig. Workzoig is an amazing WSGI. I don't know if anyone else says WSGI. I don't know why I say WSGI. Okay, one person, good. It's not just me. So yeah, it's an amazing WSGI toolkit. It's actually what underlies Flask. So Flask was originally built actually as a joke, apparently, on top of Workzoig, as what you could do as a micro framework. But then Flask obviously became much more famous. But Workzoig itself actually has a lot of the tools you need to build a WSGI application. So it does everything. The static file handling is only for development. The development server in Workzoig is great. It has a built-in debugger. I use that. They've gone to all the effort of defining all the different HTTP status codes and exceptions that you can have. So Pico just directly uses those. And then dealing with the response and the request object. we just use those from Workzoid. So Pico focuses on the things that it does uniquely. So it's built on very solid foundations, actually. And then one thing that was, deceptively simple at the start was that I thought, okay, I define my app, so app equals pico.app, and then app.expose. So this is kind of like the way it works in Flask. You have an app, and then you call some decorator methods on that app. And this works very well, simply, for single file applications. But then when you have multiple modules, it gets a bit messy and brittle because you're tightly coupling each module to the app object, which is inside one of your modules. And then you end up with weird kind of recursive imports, or you need to put your imports in specific places in the files. And it turned out to be unnecessary. So instead, the expose thing actually is a global on the Pico module. And then you explicitly register the modules that you're going to use. And the added advantage of this, it makes it easier to create third-party modules that you can add to your project. So I could create a social user authentication module that I can publish, and then other users can register that with their own application, and then use that. So that kind of solved that problem as well. Okay, so my basic conclusion here is that writing HTTP APIs can and should be as simple as writing basic Python modules for the most part. For the most part, we shouldn't need to care about request objects and response formats and all those things. We shouldn't care about where the arguments come from. The frameworks should help us to write clean and testable and maintainable code. So writing tests should be as easy as writing standard unit tests. We shouldn't have to do something specific based on the framework that we use. It should make it as easy as possible to write tests. And the framework should minimize the mental overhead, not increase it. So if you're used to using a large framework like Django or Tornado, there's quite a lot of, or even Flask, if you use a lot of different third-party modules and things, there's an awful lot of API that you need to know about. So a minimalistic framework can relieve you of some of that mental overhead, because there's a much clearer, well, once you understand it, there's a much clearer path of how data flows in and out of your application. But it's very important to understand and find the right level of minimalism. So that's what I've been doing for the past 7 years, basically. It's 7 years since I started this. I iterated a few times. At the start, as I said, it was too minimalistic. It was too magical. I didn't have to deal with certain use cases, so some things were too difficult. So then when I revisited it, I kind of tried to find the right level of minimalism that can actually help people going forward, that they can still build upon, that they can still extend when they need to, but still follow the core ideas of Pico. So yeah, in conclusion, just pip install Pico. If you would like to learn more, you can see it on my GitHub. There's also a Read the Docs site, and you can play with it or ask me questions. And yeah, finally, I want to thank, the libraries that it's built upon. As I said, it's very important to basically stand on the shoulders of those that have gone before and to build upon their work. So Workzoid particularly. Wrapped is quite useful for when you need to write proper decorators. Requests, obviously, in the Python client, and then Python itself. And yeah, nowadays the development of Pico is sponsored by Hippo, the company that I work for, because we use it internally quite a bit. So I thank them. Thank you. Questions?
Okay, we have time for one question. Thank you. I'm looking into source code of Pico, and I might be wrong, but it looks like pragmatic JSON doesn't have proper Unicode escape, which is possible vulnerability to XSS attacks.
I need to check that. I do a test for Python 3, and I do use it with Python 3, so it should work with. Do you mean a Python 3 Unicode issue, or just generally?
Just generally.
Okay, I'll look into that. There might be something that recently changed. Thanks.
Hi, thank you very much for your speech. And did you think about making Pico a bit more RESTful than you just tell us? Because I thought that if you will add just one small additional decorator which can describe parameters from URL, not just query parameters, then it will give you possibility to be RESTful as well.
Yeah. Actually, I have thought about this. And I have to admit that one of the projects that I currently use it in extensively, I have modified it to make it work with REST-style APIs because I basically refactored out the Tornado and turned it into Pico, but I wanted to maintain the external API, which was written in REST style. So to do that, I used worksite routes and overrode the URL dispatcher in Pico to customize it to basically work like that. And I've thought about trying to add that to the library, and I think I will in the extras package, because I don't see it as the Pico way to do things. I prefer the style of explicitly passing the arguments via posts, like as JSON or as query parameters, and keeping the URLs like in that simple format of package module function. I see that as the Pico way to do things, but I recognize that sometimes you need to support other styles of URLs and APIs. So yeah, actually it wasn't that difficult to support those. So I think actually documenting at least and opening up those hooks to allow people to do that when they need to, using all the routing machinery that is in Worksite, which is really great actually. Yeah, so I will do it, but I won't endorse it. That's my, yeah.
Okay, so let's thank our speaker once again.